Hello everyone, welcome sa akong pinakaunang topic about sa organic reaction mechanisms. And karon itulo na ko ang pinaka basic na principles para sa arrow pushing na ginagamit sa reaction mechanism. Now, ang reaction mechanism mo ni siya ang interpretation sa usa or duha ka organic compounds nga nag-react, okay, para ma-form ang isa ka product, para mahibal-an kung giunsa pag-transform ang duha ka reactants into a new product. Kinahanglan nato mabala ng reaction mechanism. Very important this organic chemistry, and sa reaction mechanism kailangan ma-master nato ang usaon pag-draw sa Lewis structure and ang correct assignment sa formal charge. Okay, sa naay duha ka arrows na ginagamit sa organic chemistry. Ang isa, ang kaning nasa wala mo na siya ang double-headed. Kaning double-headed arrow, ang pasabot ani niya is electron flow of 2 electrons. Whereas kaning single-headed arrow or fishhook arrow, ang interpretation ani niya is flow of a single electron. So isa ka electron ang nag-flow. So sa organic chemistry, of course, basically na ay bond breaking, na po bond forming. Nag-break ang bond sa reactants while nag-form ang bonds in order to obtain the product. Sa organic chemistry, naay duha ka klase nga chemical bond nga phenomenon. Number 1 is bond breaking and bond forming. Karon ang bond breaking and bond forming nani siya duha ka klase, symmetrical ug unsymmetrical. For example, naapoy duha ka chemical species, i-denote nato siya as say for example this one. Okay. Si A and B, na sila ang i-denote nato as duha ka atoms nga nagband sa usa't usa. Ay kung maingon tag symmetrical bond breaking, ang arrow pushing or ang arrow notation na gamiton is the fishhook. Okay, so then para ma-afford ang products nga A plus B. This is what you call symmetrical bond breaking. Kung mayroon kag unsymmetrical bond breaking, kaning duha ka electrons nga gi-share between A and B is maadto either kay A or maadto siya either kay B. So if we denote this into an arrow pushing, ang gamiton nato is double-headed, because gingon ako kanina, ang double-headed arrow is used to denote electron flow of 2 electrons, whereas kaning fishhook isa ra ka electron nga nag-flow. That is why kaning electron dot dere is naa kang A, ang isa naa kang B. Ngayon, ang product aning unsymmetrical bond breakings between A and B is this. Ang duha ka electrons naa kang B. Okay? So, si A, deficient siya sa electrons. That is what you call symmetrical and unsymmetrical bond breaking. Karon, ang sa bond forming, napod siya duha ka klase, symmetrical o unsymmetrical. Okay. For example, kani si naay duha ka species nga naay tigi isang electron, si A and B. Kung mag-form sila og bond, you will use the fishhook arrow. This is what we call a symmetrical bond formation. Okay, this is just the reverse of this one. Okay, this is symmetrical. Whereas ang unsymmetrical na bond formation is kung naa kay electron deficient nga A plus electron rich nga B, kaning electrons ni B, since electron rich man siya, it will attack A because A is electron poor. So that is what we call unsymmetrical. So ang product niya is same ra gyapon nga bond, but ang difference is the type of step sa iyang pag-form. Kung maingon ka kanang fish hook arrow, this translates to a radical reaction, and kaning double-headed arrow, this translates to a polar reaction. As mentioned, natay duha ka general reactions in organic chemistry. One is radical and the other one is polar. But sa isa ka organic chemistry textbook, maybe around 80 to 90% nga ginatackle are polar reactions. Okay, but we also need to study radical reactions. Ang radical type of reaction, nag-involve siya o ginatawag nato na radical. Kung maingon kag radical, naa siya odd number of electrons. Isa ni siya ka atom nga ang iyahang total number of electrons kay odd. Okay, just like for example, a type of radical reaction is for example, na kay radical species dire, and i-react nimo siya sa isa ka compound na i-denote na to sa as A and B. Now, ang iyang mechanism ani is with the use of a fish hook arrow. Okay. Ano siya? Oh, sorry. Tapos, kaning A and B, na siya, nag-undergo siya og symmetrical bond breaking. Kani si A and B. Whereas si radical o si A, nag-undergo siya og symmetrical bond forming. Okay. Ang example ani is can be found on alkanes. Okay. Alkanes usually undergo radical type of reaction with halogens. Okay. So for example, the reaction between methane plus chlorine, and the product would be chloromethane and HCl. Okay. HCl. Now, kani siya nga example kung if we dig in deeper sa mechanism ani, inani ang iyahang labas. Dapat ma-master jud ang usaon pag-write sa Lewis structure para ma-understand nato very clearly ang reaction mechanism sa usa ka organic reaction. So kani siya mag-break, tapos there will be symmetrical bond breaking between the C and H bond. Tapos there will also be a symmetrical breaking sa chlorine bond. Okay, so ayan siya, and then ang mabuo nga product is and napog kay HCl dire. Dayon kanida dayon si methyl radical plus chlorine radical, they will undergo symmetrical bond formation. Okay, to account for the production or to account for the generation of methyl chloride. Okay, so kanina naman si polar reaction, it's a different kind of reaction kay radical. Kay mostly sa ihang arrow pushings notation kay double-headed gyud siya. You cannot use a fish hook arrow when you study or when you write mechanisms involving polar reactions. Now, anong gitawag mo siya polar reaction? Actually, ang mga organic compounds, they are electrically neutral. Electrically neutral. Pero, there is an issue of polarization na mahitabo even though na neutral ang most sa mga organic compounds. For example, this is what we call methyl chloride. Ang polarity na nag-occur siya tungod kay there is an unequal distribution of electrons between two atoms. For example, specifically aning kangkoan kang carbon and chlorine kani siya. We all know that chlorine has a greater electronegativity. It has greater electronegativity than carbon. So as a consequence sa electronegativity ni chlorine, it will pull some of the electron distribution there is between sa ilang bonds towards the chlorine itself. That is why this molecule is polarized. Okay, tapos karon since si chlorine kay mas dako man ang electronegativity compared kay carbon, dito padulong sa iyaha ang mostly sa electron. So we can always represent this as with what we call a crossed arrow. Okay, kani siya. Meaning ani ang kaning head sa arrow is naka-point siya sa atom na mas electronegative. Kaning cross nga part is it's near the atom na less ang electronegativity. Okay. That is why most organic compounds are polar. Okay. Except sa alkanes, of course, but when you have electronegative atoms around a compound, mostly kana siya nga compound though neutral siya, it will become polarized because of electronegativity. Chemists also use annotation, what we call as delta minus and delta plus, to indicate partial positive and partial negative charge. Okay, you can use this one with polar bonds. Okay, ang partial minus will be for the atom na mas electronegative, while ang partial plus is for the atom na less electronegative. Karon ang mechanism aning polar reactions is quite simple. Okay, you just need double-headed arrows. Okay, for example, I have here an alcohol. I have here an alcohol represented by an ROH, okay, and a certain acid like HA, and mechanism ani is that this lone pairs from oxygen will abstract this H from this acid we will use a double-headed arrow for this. Okay, there will be bond formation and there will also be bond breaking, but with the use of double-headed arrows. So as a consequence, as a result, this alcohol will be protonated, and it will generate an uh, oxonium compound. Okay, plus A minus. Okay, the charge here, positive and negative, are what we call the formal charge. Okay. Ang formal charge, there is a formula for that. We need to review. It's very important to understanding reaction mechanisms para matrace po ang flow sa electrons. But we can also identify formal charge of a certain atom is a compound without using any formula, but that is the case for neutral atoms, okay, or neutral compounds, Okay, so next we will go to the prerequisites for a reaction or arrow pushings. Okay, so ang arrow or ang curved arrows denoted by this type of symbol, ang iyang nag-indicate ni siya of movement or flow of electrons. Okay, dapat kaning arrow, kaning tail sa arrow, dapat magikan siya sa site nga where there is high electron density. Okay, so if I have here an arrow, dapat kani siya nga site must come from electron rich site, and kaning arrow is it must go towards an electron poor site or less electron rich site. Okay, tapos naay daw ka klase nga sites. Okay, two kinds of sites wherein diri magsugod ang arrow. Number one is the lone pair, tapos bond. Okay, kung mag-drawing mo arrow sa mechanism, it should start from a lone pair or it must start from a bond. Okay, kanira gyud ang duha pinaka basic. It should start from a lone pair and it should start from a bond. Wala na ilain pa. So inana ang pinaka first step sa pagsulat sa curved arrow for a reaction mechanism. Okay, kung ang arrow gali kay gikan siya sa lone pair, ang meaning ana ang lone pair kay ma-remove. Kung ang curved arrow magikan siya sa isa ka bond, meaning ana the bond will be broken. Okay, sa organic chemistry, there are two species na ginadintawag nato na nucleophile. Okay, and electrophile. Kani si nucleophile, mo ni siya ang mga species nga daghan og electrons, whereas kani si electrophile mostly mo ni siya mga species nga deficient sa electrons. Okay, ang nucleophile ginatawag na siya loving. Nucleus loving siya tungod kay it loves to donate electrons and attracted siya sa nuclear charge sa isa ka from a nearby atom. Okay, whereas ang kaning electrophile, it is sometimes called electron loving tungod kay gusto ni electrophile nga mag-accept og electron from the nucleophile. Si nucleophile ang tig-donate sa electron, whereas si electrophile ang tig-accept sa electron. Sa organic chemistry, ang symbolism ginagamit for nucleophile is either this or just NU. Okay, this with a negative superscript or NU, whereas kanin sa electrophile gina-denote ni siya as E+. Okay, it's a like cationic type of symbolism. So karon kaganiyan niingon ko nga ang tail sa arrow, sa curved arrow, must come from electron rich site. So between the nucleophile and electrophile, definitely ang nucleophile ang electron rich site. So for example, na ako'y nucleophile dire and na ako'y nearby electrophile. So ang tail sa arrow, it must come from the nucleophile. Okay. And the head of the arrow, of the double-headed arrow, it must point towards or near the electrophile. Ano siya? So, question. So, some textbooks, gina-denote nilang arrow, ang tail sa arrow, gina-denote nila as coming from the charge sa usa ka species, organic species, okay, or organic compound, okay. But which arrow is correct? Actually, kung magsulat mo og mechanism, you should not start from the charge of a certain atom, okay, because that is just a formal charge, that is just a notation. Tail sa arrow should start from the lone pair and not the and not from the charge. Okay, another term is what we call as electron. Another term is what we call an electron source and electron sink. Can you see electron source? It could be a bond. It could be a bond. It could also be a lone pair. Okay. So, kaning electron source, mo na siya ang source sa electrons. Okay, from the word itself. Very understandable. Whereas the electron sink is, mo na siya ang site wherein dito mo padulong ang electrons. Okay, so ang kaning sa electron sink, most diri naka-point ang head sa double-headed arrow. So from my example, diri sa ubos, from the reaction between a nucleophile and an electrophile, ang electron source is the lone pair. This is the electron source, whereas an electron sink is this electrophile. Electron sink. In writing mechanism, always remember this: arrows will always point away from negative charges and toward positive charges. Always dyan na siya. From electron-rich source to an electron sink. Okay? Okay, so as an example of this, consider a reaction between an alcohol and a carboxylic acid. So I just denote the alcohol as ROH and carboxylic acid as this. Okay, this is acetic acid reacted with an alcohol. This is an example of a hydrolysis reaction. Okay, so ang curved arrow, mag-start siya sa lone pair. Di ba ningon ko ganina is it should come from a bond or it should come from a lone pair. But usually between the two, whether to choose between lone pair or bond, it should come first from a lone pair. Okay. Tapos you need to draw some curves it should be a curved one. Okay. Okay, so naingon ko kanina na arrows will always point away from negative charges, okay, and toward positive charges. So can you see a negative charge? No. But can you see a positive charge? No either. But we can always assume that this alcohol, ang reactive site, a reactive species is the functional group itself. Okay. So we could always denote this as hydroxyl. Hydroxide ion. And when you react with an acid, okay, this is coming from a negatively charged hydroxide ion, and ang arrow is dapat sa lone pair siya padulong sa H. Okay, tapos kaning bond between H and O, if I were to redraw it again. Okay, so one rule of thumb is that nganong ma-break man siya. That's because there are some factors nga maka-explain why this bond nag-break. Okay. Remember that a while ago I mentioned about polar reactions, right? So between the HO bond, which atom is the more electronegative? Oxygen. So therefore, ang electron density is more siya towards oxygen. The electron density shared between H and O is kaka-shift siya towards oxygen because this is more electronegative than hydrogen itself. That's why it makes this hydrogen less or it makes this hydrogen an electron poor species. So this one is an electron source. So the lone pair is the electron source and the H is the electron sink. Okay, and one rule of thumb is that ang octet rule, the law of 8, okay, the law of octet must be strictly followed. So in this reaction, product niya would be water and acetate ion. Okay, this is an acetate ion. So yung ko ganiha na dapat ang octet sa isa ka atom or of all the atoms, it should be conserved. Okay, that is why when this lone pair attacks the hydrogen, mag-break ni siya nga bond. Kaya nga naman this OH before ni siya gi-attack ni kani siya nga oxygen atom, before ni siya gi-attack ni hydroxide ion ang H, kompleto ang iyang octet. Okay, so 2, 4, 6, 8. Okay, kompleto ang iyang octet. This one is 2, 4, 6, 8. Remember that ang isa ka single bond nag-represent na siya as 2 electrons. Okay, 2, 4, 6, 8. So kompleto pa yung octet. So ang rule of thumb is kung nagali isa ka atom gagini-attack unya ang next atom is kompleto ang iyang octet, dapat kaning bond between them mag-break gyud na siya. Okay, para ma-preserve to ang iyang octet ni oxygen because atoms always love octet, okay, of electrons to attain stability. That is why ang kaning bond dere, kaning duha ka electrons, it will be drawn towards oxygen. That is why mao ni ang representation sa Lewis structure sa product. kaning bond diri na himo siyang lone pair. Okay, that's one principle that every one of us should strictly observe. So I have here another example. Okay, if I would draw this. So, it really takes a good practice sa pagdraw sa Lewis structure. Okay, so it's very important ang pagdraw sa Lewis structure kay by drawing the correct Lewis structure, matrace nimo ang og insakto ang flow sa electrons. Okay, so there are two reactants here, the thiol and this ester compound. Okay, yeah, saturated. Okay, so first, the electron source would be the lone pair from thiol. Okay, this will be the electron from thiol, so it will attack this carbon, of course. And next, since ang next carbon is complete ang iyang octet na siya 2, 4, 6, 8, one bond must break. Okay, and this double bond should break. And notice that kaning next carbon, if we are going to number the carbons, no, 1, 2, 3. Okay, kaning si carbon 1, notice nga kompleto ang iyahang octet. So since kompleto man yung octet, a bond from here must also break. So that is why this one should go towards oxygen. And very obvious siya because between carbon and oxygen is more electronegative. Mao na nga it will pull the electron shared between the two towards itself. So very insakto jud ang arrow not towards this oxygen and not from this oxygen. Okay, kay nga naman kay kaning oxygen nga sp3 oxygen complete naman yung octet. Yes, complete ang octet ani 2, 4, 6, 8, and also this one 2, 4, 6, 8. But if you will break this bond, you will have a formation of another compound. Okay, so naa kay nani so mo na imong product which does not obey the octet rule. Okay, this Lewis structure is very incorrect. So this is one way of tracking down the correct mechanism. You cannot have a positively charged carbon nga tetravalent. No, kaya na-attain naman ni carbon ang octet 2, 4, 6, 8, it cannot have a charge, either positive or negative. Okay, and that is why ang flow sa arrow should be to the sp2 oxygen. Okay, and so for this one the product would be no. This should be the product. And notice that from here to here, okay, Um, there's also another way to determine kung tama ba ang mechanism. That is by looking at the charge. Okay, from here ang charge ani is -1 because of this thiol. Okay, and sa product ang overall charge sa compound is also -1, which is attributed diri sa oxygen. But kung kani nga pathway ang imong sundon, kaning ma-detach ang kaning methoxy group, the overall charge of this compound is 0, which is not equal to the starting to the overall charge sa duha ka reactants. Always remember that there should be conservation of charge when you do organic reactions, even sa inorganic reactions. So the charge on the reactant side must be equal to the product side. That is why kaning pathway nga kani siya nga pathway is not the correct mechanism, because sa reactant -1 ang overall charge, while sa product na kay 0 charge. Okay, that cannot happen in reality. Okay, another example is a reaction between trimethylamine. Okay, this is trimethylamine and methyl iodide. Okay, this will undergo as a substitution reaction. So, what could be the product of this one? Okay, remember that this alkyl halide, this is a polar compound. Okay, because iodine is more electronegative than carbon, so the electron distribution between the covalent bond can be found more sa iodine. Okay, that is why this bond will tend to break easily, and we can also attribute that sa ionic size sa iodine. Okay, this bond is very weak, okay, because of the size sa iodine. Due to the bigger size iodine, it is more polarizable and mas longer ang iyang bond length. Okay, let me show you some example or comparison between fluorine, chlorine, bromine, and iodine. Diba? Ang electronegativity is increasing, whereas ang ionic size or atomic size is increasing in this order, okay, or in this direction. Okay, iodine has bigger size than bromine, and bromine has bigger size than chlorine, and chlorine has bigger size than F. So in this, if we are going to compare methyl fluoride, methyl chloride, and methyl bromide, and methyl iodide, which bond is weaker? It should be the methyl iodide. That is why this bond right here, the methyl iodide, can be easily attacked by the strong base trimethylamine. Okay, i-attack niya si carbon because this carbon will have a partial negative charge, and this one partial positive charge, and this one is partial negative charge. Okay, so if we compare it with assuming that this is methyl, assuming the same sila size, and this one is fluorine, this one is chlorine, this one is bromine, this one is iodine. Okay, okay, this is fluorine, this is fluorine, this is chlorine, this is bromine, and this is iodine. So, ang pag-determine sa bond length is between nucleus to nucleus, right? So this one. So which bond is longer? The CF, CL, CBr, or CI? So in this case, it should be the CI bond, CH3I bond. So meaning to say, when you have longer bond lengths, or when you have longer bonds, it means it's a weaker bond. Okay, that is why this methyl iodide is an effective reagent for when you want to experiment about substitution reactions. Okay, so in this case, flow sa electrons will be from the lone pair from this nitrogen, which has a complete octet. Okay, 2, 4, 6, 8. So this will attack this carbon nga electron deficient. Okay, and since iodine is an electronegative atom, it will pull these electrons towards itself. Okay, and since this CI bond is weaker, dali ra ni siya ma-break the bond. So that is the principle behind this kind of reaction, this SN2 reaction. You have the bond length and also the electronegativity. Okay, so ang product therefore is this. Okay, notice that all of the atoms here have, in the product, all of the atoms in the product have complete octet. This iodine has a complete octet, 2, 4, 6, 8. This nitrogen, 2, 4, 6, 8. And all these carbons has complete octet. Okay, so notice also that the overall charge from the reactant side is 0. Okay, and the overall charge in the product side is 0 because positive plus negative is 0. So that's how you are going to write the mechanism of this kind of reaction. First, you need to determine the electron source, which is either a lone pair or a bond, and determine the electron sink in a compound, and you can assess which is the electron sink sa compound by, of course, assessing the electronegativity or atomic size of the next atom. But most of the cases is, since polar compounds man siya, electronegativity jud ang factor nga mag-dominate because this shared electrons right here will be pulled towards the more electronegative atom. So to summarize this one, this electron flows towards this electron sink, and these shared electrons will flow towards the iodine. Okay, so and the product will be an ammonium compound and an iodine ion. Okay, so today at this point in time, I will talk about the common errors in arrow pushing. Okay, first would be ligand rich versus electron deficient errors. Okay, an example of this one is when you see these two types of species, this and hydronium ion. Okay, so at first, for non-chemists, as what I mentioned a while ago, is that an electrophile can be denoted as E+, right? So it loves to accept an electron, and you might consider or treat this nitrogen as an electrophile and this oxygen as an electrophile. Okay, but actually it is not. Okay, so if you have a nucleophile here, and you react this with the ammonium ion or hydronium ion, okay, just by looking at the chemical formula, murag atong maingon is dapat kaning lone pair is mo-attach sa nitrogen or sa oxygen. That is incorrect. Okay, first we must write or draw the Lewis structure for ammonium ion. Okay. If you have a nucleophile here, this is the charge. The formal charge must be in nitrogen. So when you draw it like this, the arrow, this will form this one. Okay, this is actually incorrect, okay, because when you draw the mechanism as like this, it will give the nitrogen 5 bonds, or it doesn't anymore satisfy the octet rule because nana siya 10 electrons, 2, 4, 6, 8, 10. Remember that carbon, nitrogen, oxygen, and halogens, they obey the octet rule. Okay, and another thing is that when you have a nucleophile and a hydronium ion, and you tend to draw the mechanism like this, this is very incorrect because it's also the same thing as the one I've drawn above. Okay, oxygen does not obey octet rule anymore because you have 10 electrons, 2, 4, 6, 8, 10. This is incorrect way of writing the mechanism. So instead of this, you should write this in this manner. You should draw the mechanism in this manner. You have a nucleophile and you attack the proton because between H and N, nitrogen is more electronegative. It makes this hydrogen electron poor. Okay, that is why these electrons will be drawn towards nitrogen, the more electronegative atom, and the product would then be nucleophile H plus a neutral atom. Okay, remember that this bond will form a lone pair. Remember what I mentioned a while ago. Okay. Remember that a lone pair will be converted into a bond, or a bond will be converted into a lone pair. It's just dire na gina siya gadula ng principle. Okay. Na mag-reverse na gina siya. So the overall charge for this reactant side is 0. Okay, because negative plus positive is 0, and on the product side the overall charge is 0 as well. So in this example also, this nucleophile will attack the H, and this bond will be turned into a lone pair because oxygen draws the electrons from this covalent bond towards itself, since it is more electronegative than hydrogen. So that is why the resulting products are this plus water. Okay, so again the overall charge on this side is 0 and this side is 0. So that's how you write the correct mechanism. And another error is what we call electron flow backwards error. This type of error is commonly found on biochemistry textbooks. Okay, so first I have here an example. If you have a proton here and curved arrow is from this proton to the OH and money siya ang product, no, this is very incorrect way of writing the mechanism. You cannot write a curved arrow from an electron sink to an electron source. Okay, it should be from electron source to an electron sink and not the other way around. Okay. Some textbooks in organic chemistry will show you this kind of mechanism, but it's totally incorrect. But the authors might just want to say that you add a proton on this say alcohol compound, and your resulting product will be a protonated alcohol like this. But you don't have to use this curved arrow because it might represent the incorrect flow of electrons. Okay, remember that the positive charge cannot flow, only an electron. Okay, and another error is what we call electron flow continuity errors. Okay, an example of this is can be found on S interreactions. For example, I have here a nucleophile and an alkyl halide. Okay, so usually if you draw the mechanism like this, from the lone pair to this electron sink, and you just write the product as this one. This is actually incorrect. You always show the flow of electrons. Okay, so in doing so, you need to add another arrow from between this carbon and iodine, and this is of course understandable because iodine is more electronegative than carbon. That is why the arrow is depicted like this. Okay, the electron should be towards the more electronegative atom. Okay, another error used in writing mechanisms is curved arrows that bounce or miss their target. Okay, one example is this. Okay, so an example of this is the reaction between a certain electrophile and say nucleophile. So some students, especially the new ones in mechanism, they would normally write it this way and that way. This is actually incorrect. Okay, you should not miss, okay, the target of your arrow pushing. So instead of writing this one, the correct writing of mechanism of arrow pushing should be like this. should be directly towards an electrophile, okay, and not a neutral compound or a neutral atom, I mean. Okay, it's because this, if we number these atoms as, or if we label these atoms as carbon atoms as A and B, and see carbon A and B, they are both equally stable, like they have complete octets. So there's no way, or there's no basis for writing the flow of the arrow towards from carbon A towards carbon B, because they are just the same. They have complete octets, and this carbon B doesn't need a another electron from a nearby atom because its octet is complete. Okay. So as a product of this kind of reaction, it should be this. This carbon should form an it should have a positive charge, okay, because the electrons, this pi electrons, remember this is sigma and this is pi, this pi electrons would attack this electrophile, and usually actually ang positive charge pwede siya sa carbon B. It could be carbon A, you could write this with carbon B, but the most, when writing the product, or when writing possible drawings the Lewis structures of product is the one that is the most stable. Okay, so if we write the other product, this one, if we choose between 1 and 2, the possible structure of the product should be this and not this, because you know carboxyl ions are stabilized by hyperconjugation. Okay. So a tertiary carboxyl ion is more stable than a primary. Always remember that kind of stuff. So this should be the more plausible formation of the product. So in summary, these are the what we call good habits. Good habits. No. This is, I will try to use some good arrow pushing habits. First is that number 1, draw Duet structures near any arrows, okay? And para matrap nimo ang atoms and electrons along the course of the mechanism. And number 2, okay, so number 2 is start every arrow from a drawn pair of electrons, or what we call lone pairs in this kind of example that I stated or explained a while ago, and not from a minus formal charge. Okay, for example, you have a nucleophile and react with the nucleophile, you should not draw the arrow like this. It's incorrect notation. It should be drawn like this. This is incorrect, and this one is the correct our drawing of our pushing curved arrows. Okay. Number number 3, to assess kung tama ba ang imong mechanism control, is you need to check the following: tapos octets and duets. Kaning duets is exclusive for hydrogen, okay, because hydrogen follows the duet rule. You can only have a maximum number of 2 electrons in its valence shell. And number 4, you need to check formal charge and charge balance. As I've mentioned before, the charge of the reactant, overall charge of reactant must be equal to the overall charge of the products. Okay, so number 5, you should use the known electron flow paths. Okay, so kaning known electron flow paths, I have not discussed it yet, but on my next YouTube video I will discuss about electron flow paths in organic chemistry. Okay, there are lots of electron paths actually that we should need to familiarize in order to write the correct reaction mechanism. So for now, that will be all, and thank you for listening. I hope that naamoy natun-an ani akong lecture videos.